This video has been created for Mount Druitt College of TAFE. It has a Creative Commons 3 non-commercial share-alike license. In this practice, you'll be stripping insulation from wires. Several types of wire strippers and cutters are available. Be careful not to cut the strands of the copper wire. The wire which has been chosen to work with here has 30 individual strands, each strand being 0.038 square millimeters. Some cheaper tools may damage the individual strands of wire and must be avoided. Visually check the wire which has been stripped for any damage that may have happened to the individual strands. If damage is seen, strip a new fresh section of wire. Carefully note the natural lay of the strands of the wire and then slowly wrap them together to make a nice tight end to that wire. With a 30mm section of the copper wire exposed, bring the clean tip of the soldering iron to the wire and make a heat bridge with the standard 60-40 tin lead solder. Hold the soldering iron in one place and move the rosin cord solder to completely tin the wire strands, but do not let the solder wick underneath the insulation. Examine the soldered joint for any signs of defects. Defects include flux inclusions and areas of non-wet which still show the copper with no solder tinning. This is obviously a defective solder joint and it will have to be redone. The first step in the process is to start with a clean soldering iron tip. Then apply a small amount of solder to the tip. This is what we call tinning the tip. Take the tip to the wire, hold the tip in one place, make the heat bridge, which will allow a lot of heat to go into the wire, and then move the solder to completely tin the wire. The visual inspection here shows that there's no areas of non-wet and there's not too much solder at any point on the wire. It's a perfect tin connection.
To the big show.
Okay, so last week I had to travel to San Jose on business. I called about 3 hotels. They didn't have anything. Apparently there was a Macworld convention going on or something, but I did call a hotel that had a room.
Now that we've already done one very successful tinning of the wire with the solder, it's very important to understand that not all solders have the same characteristics. If you had chosen to use the multi-core Alusol, then things certainly wouldn't have gone quite so smoothly. In fact, if we examine the contents of the Alusol, it's designed for soldering to aluminium and aluminium alloys, stainless steel. It has approximately 18% tin 80% lead and about 2% silver. Although it can be used to solder copper wire, it requires a lot more heat and a lot more practice to use this type of solder. Be sure that you clean the solder to remove any grease and any impurities.
It was a little bit out of tune, but I played it anyway. But the melody that played...
We go ahead and we make the heat bridge. We can see a lot of white smoke from the rosin burning. But quite obviously, the solder does not want to flow. The soldering iron's running at approximately 320 degrees Celsius. Normally that amount of heat would be fine with 60-40 solder, but with this particular solder, we're really starting to encounter some problems.
They don't, have rooms for guests on the third floor, but they have stuff up on the third floor, offices and whatnot up on the third floor.
The big show.
And at 10 o'clock at night, when he was there all by himself up on the third floor, because the offices and stuff are closed at 10 o'clock at night, the lights went out.
Increase the heat on the soldering iron to more than 360 degrees Celsius and try again. Marginally better, but still really not what we would expect.
He's by himself, and all of a sudden on the other side of the door he hears some knocking.
That's the problem.
That's what Peter told me.
The big show.
Denise told me at 3 o'clock in the morning the phone in her room rang.
Normally we would have a satisfactorily tinned copper wire, but we visually inspect this one and we find it has numerous problems. It's really been a total disaster with that type of solder. Now to twist two wires together and complete a soldered joint. It's a slow twist. We don't want any high spots or low spots in it because usually after the soldered joint is completed we'll want to put some heat shrink tubing over the top of this to act as new insulation. As before, we'll start with a clean soldering iron tip, tin it with a bit of fresh solder, take it to the job, make a heat bridge, and basically keep it in one position while we move the solder to the various points on the wire that we're soldering. Don't worry if it seems to take too long to complete the soldering process. This is a very large joint with both pieces of copper wire wrapped one over each other. It needs a lot of heat and more time than would normally be required to do just tinning on one wire. The finished joint will be very hot. Never blow on it or attempt to cool it. Just let it cool by itself. Visual inspection shows a near perfect joint. All of the individual strands of the wire are still visible. There's not an excess of solder. There's no excessively high or low spots. The finished joint now is ready to have some heat shrink tubing placed over it if required. The last part of this soldering video is dedicated to making the bus bar which runs through the switch tunnel for the Arduino project. To do this we need to first of all strip off about 150 millimeters of insulation from the supplied wire. As we did before, we have to find the natural lay of the wire and slowly twist these together to make them tight and secure. Locate the outside eyelet in the very end switch, and then with the piece of wire, neatly insert it just through that eyelet. We'll solder the eyelet with the bus wire on the final switch first. We may need to leave the iron there for quite some time to observe the flow of the solder and make sure that we get a good solder joint. Don't be in too much of a hurry for this.
Art is born.
Use the small pliers to adjust the position of that bus wire, and then proceed to solder it to the second switch and the third switch. Again, don't be in too much of a hurry, and watch carefully what the solder is doing and make sure that it makes a good secure soldered connection.
Still can't regret my big sin, though I acted a fool. My double become a real has been.
There are 3 LEDs to be soldered onto the bus wire. You must first of all identify which is the cathode. The cathode is always the shortest leg on the LED. There are 2 other methods of identifying the cathode, which you'll see shortly. First of all, take the cathode and bend a small hook on the end of it, hook it over the bus wire and crimp it into place with the pliers.
Still can't regret my big sin, though I acted a fool. My double become a real.
As with all semiconductors that you have to do some soldering with, be very careful not to let too much heat travel up the lead of the LED. It may damage it.
How you become what you've seen too much of, so I might have been. Now there we say our goodbyes.
I did say that we would see 2 other ways to identify the cathode. The cathode is the large element inside the LED, and if you look on the plastic on the outside, there's a flat edge adjacent to the short lead, which is always the cathode.